Okay, so what do you think? Why does the character class exist? Anybody have a good answer for that? Go ahead.
To hold the value of the primitive type of the char literal.
Okay. Why do we need two ways to hold the primitive type char? Don't we already have a way of holding a char inside of a char primitive type?
To basically perform different function to the char literal.
Okay.
Converting to lowercase, uppercase.
Sure. And so why do we need the character class for that? I mean, you're right. You're going down a good path here. So can't the char do that stuff itself? Why not? Yeah, it's a primitive type. Primitive types are built into the language and they can only hold the value. That's the limitation on their talent, right? So if you want to do stuff to char primitive types, convert it to uppercase, ask it if it's a digit, ask if it's a character, ask if it's a letter, that kind of stuff. We need a tool. We need something else to do that for us, right? Or we have to write those functions ourselves. So if there's a collection of functions that we think should exist, at the minimum for doing things related to chars, we're going to need an object type to do that stuff for us. Okay. Now, second part of this question is why is it filled up with a whole bunch of static methods? Go ahead.
Because you don't really want to have to make a new instance of the character class every time you want to do something fancy with your chars.
Okay, so you say we don't want to make. Would it make sense to make? When we create instances of something, create a new variable for a string or something like that, the main feature of that is to do what? Hold the value? I mean, when we create a variable, the number one reason is to hold a value. We might then choose to do some other stuff to it. All right, so if the character class had a whole bunch of instance methods in it, non-static methods, like we talked about last time, in order to access those guys, we would need instances of the character class, which means that we would have we might create a character class, a character object to hold the char a, or another character object to hold the char question mark, that kind of stuff. But we already have containers for holding chars. It's called the char primitive type. So we don't need that talent. We don't need to create a second. This kind of reminds me. I think it was it Whole Foods? They were in the news kind of 6 or 7 months ago. This was before Amazon bought them. They had, I think it was it an orange? I think it was oranges, and they had oranges packaged in a thing for holding oranges. Was it oranges?
Yeah.
I mean, oranges come with their own packaging, right? I mean, God put this thing on it. Okay, so I mean, that's just a waste of material to put, unless you eat the peel. And then you want to wash it a bunch, but you probably don't want to throw an orange on the ground and play soccer with it for a little bit and then pick it up and start doing the orange rind thing like the chefs do, right? I mean, do you actually eat that, or is the zest thing just for like a flavor thing? Do you actually eat the zest? I mean, I'm a fat guy, so you just eat anything that's in front of you. So I'm kind of like a dog like that. I determine whether I should put something in my mouth by putting it in my mouth. And then if I say it's not edible, then I spit it out.
Not quite. The dog would actually eat that paper cup you're using.
I'm not done drinking it yet.
Fair.
You don't know what happens after class. I always find it interesting. Dogs have this, we assume that dogs just eat anything, right? Yet most of my friends who have dogs, they have really picky eater dogs. Extremely picky. There's some video on the web that was, having dogs comparing Burger King to McDonald's, I think, cheeseburgers. And like they did this over multiple days with the same dog. That dog always picked Burger King. Wouldn't even touch the McDonald's cheeseburger. I found that fascinating. I mean, heck, I don't even care what kind of cheeseburger. Like, look, it's a fast food cheeseburger. Just eat it. It's not good for you. You know, after about the ninth, I mean, maybe some of you don't get to a ninth cheeseburger, but I get to a ninth cheeseburger. Then it doesn't matter anymore. All right. All right. So, fill with static methods because we don't need to individually hold a bunch of characters. Instead, we kind of need this factory, right? And we got this factory that we can send our chars to and say, here, I want you to make this guy uppercase. Or here, tell me if this guy is a number. That kind of stuff. I don't want to have to create anything, right? I want to just take my char into the store and have it give me some information about that char. So that's why it's filled up with static methods. We only need those functions to exist once because we do not need it to hold values. We don't need that object to hold a value because we already have the ability to hold a value. Make some sense? All right. Now, something we saw last time. Is inside of java.lang. Remind me, what's java.lang again? Yes, it is a package, and this is the standard Java language that automatically comes with your Java program if you don't do anything special. Right? There's an invisible import statement at the top that's like import java.lang.star. Give me access to the entire core Java language, which is plenty of stuff, but it's not that much stuff. We kind of looked at it last time, and we could scroll through that pretty quickly. All right, and a lot of these you'll never use, but they're available to us because, I mean, Java is a general purpose language, so this is kind of the minimum common denominator of things they need that they think you need to solve a general classification of problems. But as we look through here, we see a Boolean, we see a byte, we see a character, we see a double, we see a float, we see an integer, we see a long, we see a short. We're going to talk about strings today. All right, so we have object types here for working with all of our primitive types. So won't that argument we made for today's quiz be the same argument for all of those? We have primitive types for holding bytes and shorts and ints and longs and blah, 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 blah. But those guys can't do anything to themselves because they're only primitive types. Their talent ends with just holding a value. So if we want to be able to do things to those types, we're going to need a factory for doing stuff to them. So do you suspect when I click on double that we're going to find a bunch of static methods in there? For the same reason why there's a bunch of static methods inside of more static, whether a number is infinite. That's interesting. How would it determine that? So I guess gigantic number? Because a double, I mean, it doesn't, that's a really weird function. Wonder when we would use that. I mean, it seems like if that's just asking if a double is nearing the maximum size of a double. Because a double is 64 bits followed by a decimal point followed by 32 bits. And it's signed. So that means it's plus or minus 2 to the 63rd power. Which, it's a really big number. I mean, that is a big number. But not infinitely big. I think it's like quintillion, something 16 point something quintillion. I think it's in that ballpark. I mean, it's not a number we often use or stumble upon, but it's certainly less than infinity. Yeah, whatever. Bunch of static methods. Okay, same thing's true for these other guys, long and things like that. Now, we see we have some other objects in here that, you know, we'll stumble upon some of these. We'll use the math library at some point. We will use the thread library, but not soon. We'll use it eventually. Okay, so let's talk about strings. All right, so last time we discussed our primitive types, we discussed the need for being able to do things beyond that. Now, a statement I often make, and I might have it in the slides already, but let's just throw it in here again. For strings, Java is a string-based language. All right, now, that's more of my take on things. I don't know that you'll find that in textbooks and things like that, but certainly from a problem-solving perspective, you're going to see this. But in Java, strings are very, very malleable. So if you can get something into the format of a string, we can do all sorts of stuff with it. Okay, so string is almost a universal form for us in Java. They're very flexible for us to work with those things. They're also very easy to create. So before we start talking about the string class itself, and we saw this in Python, let's say I have an int a is equal to 5, and then I want to have a string s, and I want this guy to be the string version of whatever's currently in a. How do I do that? We did this in Python. Go ahead.
Would it be something like string and then open paren a?
Okay, so incorrectly, he wants to typecast it, right? So you would do something like that.
Yeah.
So that's our typecasting go-to move. Yeah, that's not gonna fly. Because now, I mean, and part of it has to do with the fact that you're trying to typecast a primitive to an object, which is gonna have all sorts of issues. Remind you here, we definitely dealt with this in 200. What's that guy? The empty string. So we got this powerful tool in most of our programming languages. Python's one of them. Java's another one. And it's a very simple tool. We dealt with empty strings last semester, right? Remember this? Okay. The empty string is a string. That's the most important part. This guy is a string. And even though you're going to say this isn't a word, that in fact is a programming term. Something is a something else. So the empty string is a string. It just happens to be a string with 0 length. So that means we can use it as a building block for building strings. Now, we also had something called concatenation. Concatenation. Is that right? That looks right. Nailed it. All right. What's concatenation?
Gluing.
Yeah, gluing stuff together. So fancy word for gluing stuff together into a string. And we also would say that one of the sides of the concatenation operator must be a string. That's a rule. Otherwise, concatenation operator won't be treated as the concatenation operator. Concatenation, what was the concatenation operator in Python? Plus sign. Guess what it is in Java? Plus. It is also the plus sign. Where do you think that came from? I heard him say minus. I just figured he was so wrong about the string typecasting thing. Which actually, I'm glad you gave that answer. Did you give it on purpose?
I actually completely forgot about the empty string.
Yeah. So you actually thought that might work.
Yeah.
You know, actually, I'm going to give you this. I'm going to say there might be a 1% chance that in Java 8 that could work. But I'm pretty certain it won't. So.
There's a chance.
I really don't think there is, but I'm going to stretch it to that 1% because we did see that weird behavior last time. I was showing you the static versus non-static methods because it didn't work on hers. On her laptop, it worked the way I suspected it would work. Did anybody else have, I mean, the thing I was saying last time that should have caused an error, that should have caused an error. Was it an error on most people's machines? The thing where we tried to say this dot. Let me open up Eclipse again. So for, do I have another function here? Here, I'll do it this way. So we're going to say static void do something. And then we maybe would say this dot. Yeah, see, I'm getting the error now. Yeah, you cannot use the this keyword inside of a static context. I was talking about contexts last time, right? So I have no idea what was going on last time. But in any case, because this guy is static, this keyword this, which we haven't talked about yet. We did talk about it last semester, though. Remember last semester, kind of near the end when we were working with objects, we had this thing called self dot. This and self are the same thing. Right, so this is how Java, an object in Java refers to itself within itself. Since I'm in a static context here, though, this kind of gets back to our quiz question today. The reason that I am static is because I don't have multiple copies of myself. There is no this. I'm a factory that's up on the hill that's just meant to take parameters in and do something with them. So I don't know about this guy. Because there isn't a me. There isn't multiple copies of me where I'm talking about a specific copy. So inside of a static context, we aren't able to call non-static variables. Okay. Similarly, if I make this a static context, notice that this guy's okay with this now, and I say this dot, yeah, see, this is the guy that should not work. If I say this dot make change, this is a static function. Therefore, it's owned by the class itself, not by an instance of the class. This is how an instance refers to itself from within itself. So make change 1020, something like that. It's giving me a warning here, but this should be an error. It says the static method make change from the type driver should be accessed in a static way. Although it does seem like it's allowing me to access it in a non-static way just because it wants to make my life easier. But you said this does not work on yours, right? Very interesting. But the fact that it's giving me the warning, it is noticing the problem, but that should be an error because it is not correct to access a static method through a non-static context. That's not legal code. That's the whole the fact that we would make a method static or not static indicates that is a meaningful thing to do, right? So we shouldn't be able to access those things through that this keyword. All right, so getting back here, concatenation in Java, same as concatenation in Python, plus sign. You'll find that pretty common in many languages. It's the plus sign in C#. It is the, I do find it actually interesting, though, on the Apple side of things. Objective-C, messing with strings is not as easy. In C++ and C, well, you do. I mean, a string is a char pointer. Well, I guess it's a char pointer in C. So the way you can do concatenation through scanf using %p and %p. So to be honest, even though that sounds kind of like, I'm not going to go into that, but that sounds like a complicated-y type thing, it's actually not bad. In fact, sometimes Java does have a thing like that. At some point, I'll show it to you. But these are called placeholder variables. So sometimes, let's say you're building a sentence. You want to say, oh, the number of pennies is this, and the number of dimes is this, and all that stuff. And we put them on separate lines, right? Because we hadn't looked at concatenation yet in here. Well, let's say you wanted to have this big old paragraph with variables inserted in there. It would get pretty old pretty quick if you're kind of having to write the first part of your sentence, then concatenate onto that some variable, then concatenate onto that some more of your sentence, then concatenate onto that. That starts getting tedious. Well, there is a format function in Java that comes from the printf function in C, where there are these placeholder things. %f is for a float, %d is for a decimal, %i also works in more modern compilers, %s for strings in a newer compiler, %p for strings in an older compiler. But the point is you can write your entire sentence out and just put these placeholders in there without using concatenation, and then it will effectively do the concatenation thing for you. And if the language you're working with doesn't have that, you can always write it yourself. I mean, it might take you a few minutes to write that function, but it might make your life a lot easier moving forward if you're having to do a lot of concatenation type stuff. Not as common today as it would have been historically, because a lot of our applications today have graphical user interfaces. So we're not dealing with a bunch of textual output at a command line or something. So
The 10-year age gap might have something to do with Objective-C and handling strings in a different way.
And here's why. I mean, so that's not an unreasonable statement, right? Swift is crappy with strings too. Okay? And with Swift, we have a 17-year age gap? No, 20-year age gap in the other direction.
Right.
So the Swift programming language is, let's call it out of our main languages, the newest. It is not friendly with strings. It's very interesting. It is difficult to work with strings in Swift. Which, I mean, I've advertised Swift as being Apple's goal to get people to come over to the dark side, right? So you would think that if they're trying to get Android developers, Java developers to jump ship and come over to Apple, as a Java developer, your go-to move is working with strings. I mean, you're going to see just how flexible they are. But since your go-to move is working with strings, you would think they would want to make strings easy to work with over on the Swift side, and they really have not. In fact, I would actually say Swift is impressively bad at working with strings. Yeah, it's not just not easy. I would say it's actually difficult for working with strings in Swift. Or manipulating strings in Swift. Working with them is fine. It's easy enough to define a string and print stuff and that kind of thing. But if you want to start changing the values of strings, gluing them together, stuff like that, you got to go to like a format type thing like we just talked about, which at the end of the day actually becomes a fairly handy tool. But modern programmers, because of when they started programming, they're not used to that. Because most of our modern programmers are going to be like the 20-somethings, right? Or 30-something, where they probably did not grow up learning C and working with an older language like that. Some universities are still teaching a C programming language, probably 80% for no good reason, but 20% I think there is value in seeing how some of those old languages work, because they're not.
Harvard uses C in their introduction.
Sure.
Science course, so.
Yeah, I think it's certainly a poor language to teach the entire course in, I think, today. I think Python makes a lot more sense for our first language today. I think Java isn't horrible for a first language, but Python might be a little bit lower barrier. I do think it's important, though, to have a couple of those kickbacks to some of these older languages and just kind of see what it was like. I think that's enough, because you're not going to have a whole lot of reason for being really, really comfortable in the C programming environment, unless you go into something with operating systems or back-end for game design type stuff. But even then, that's becoming less and less of a tool that they're using. So I don't know how much value there really is in there other than an academic value. Okay, so concatenation, gluing strings together. In order for Java to detect you want to concatenate, at least one of the sides needs to be a string. Because So this guy looks fairly familiar to us because we also use that for addition, mathy stuff. And you probably don't want to say hello plus 5 and get some sort of math answer. I don't know what answer we'd expect, but probably not the one you want. All right, we want that guy to be treated as concatenation. So now, having said that, a power tool that we have is working with the empty string along with concatenation. Because now what we can do is we can do something like this. Whatever value a is, in this case a is an integer, and it happens to hold the value 5 here. So this will resolve to the value 5. It's going to go and look up a in memory, go to the spot where a's value is, see it's a 5, and this guy will turn into a 5. So it'll look like that at runtime. And then it's going to take that and it's going to apply the plus operator to that plus this guy. So what are the types on either side of the plus operator? We have a string on one side. We have an int on the other side. Because we have a string on at least one side, it's going to treat that plus sign as the concatenation operator, not the addition operator. Therefore, what it's going to produce is that, the string 5. Make sense? So building things onto the empty string is a very, very, very important tool for us in Java. In fact, it's going to be a pattern that we're going to use a lot in our problem solving, especially given the fact that Java is so string-centric. All right, so questions about concatenation and empty string, and at least a high-level idea of a string? Because really, what's a string? A string is a double quote followed by 0 or more chars, followed by a double quote. What's a char? So what kind of things can be in here? When I say 0 or more chars, maybe you could also maybe re-say this as a collection of chars. That's what a string is. It's a collection of chars, and it's surrounded by double quotes. But what's a char? What kinds of things might we find in between the opening and closing double quotes of a string? All right, we'll do multiple choice. So we have cat, we have dog, or anything that's in the Unicode character set. See, anything I actually didn't label them, so really it could have been 3. Yeah, 1, 2, or 3, or it could be 0, 1, 2. So in that obvious example, you actually got it wrong. It was a 0-based list. 0, 1, 2. I didn't say it was ABC. Understand the problem before you try to solve it.
The most just refer to it as most recent array in memory, index 2. But actually we want index 3, all of the above.
Well, you got to do plus size of answer type, which would be size of string, which is an arbitrary size. Now you're still in trouble. So you have to do size of pointer. That'll work. If you missed that joke, we'll talk about when we talk about arrays. It is a geek joke, but it is a funny one. All right. Some of you might not find it that funny even after we talk about it. It really has a measurement of just how sad your geek life has become. All right, so it's a char is anything that's represented on the Unicode character set. So 65,536 unique characters indexed between 0 and 65,535. Okay, so these are things like A and B and question marks and spaces and commas and symbols from all sorts of different languages and all that jazz. That's the stuff that can live between the opening and closing double quotes. Make sense? Strings, I'm sure, do have a maximum size. I do not know what it is, which is very interesting because it's something that I would have thought I would have looked up at some point. I'm going to guess it's size of long. Let's just look it up here. Max string length Java. It's either size of long or size of int.
2 to the 31
Yeah, so it's size of int. So the unsigned portion of an int. So 2 to the 31st power minus 1, so that's 2.1 billion. So minimum number of characters in a string is 0. Maximum number of characters in a string is 2 to the 31st minus 1, which is 2.1 billion. 2 to the 31st. Yeah, 2.147, 2,147,483,647 maximum number of characters in a string. So how many characters are in like your average textbook, like an average book? Is that like in the hundreds of thousands? That's not billions, right? So we can hold like really big documents. Another interesting question. Characters in average book. So a typical book has, well, standard format hardcover book has 300. That's the number of characters on a page.
Yeah.
Yeah, so 1,800 times, what's the book length? 500 pages?
That's good.
900,000 characters. So we can hold a whole book in a string, and then some. So we're good. Lots of wiggle room. But it is not infinite length. So if you need to hold a whole lot of characters, understand strings might not be the tool for you. Okay, so 0 more chars, collection of chars, blah, blah, blah. Concatenation operator. We can easily build strings with the double, with the empty string operator. These are beneficial things to us. All right, so I'm going to introduce, well, first, let's go to the flip side of static methods. Because at this point, all the methods we've written, we've just arbitrarily put static out front because I just said, just do it, ask me later, right? Now's the later. All right, we already kind of talked about the static side of things, but that didn't really give us the reason to switch. We just kind of stuck with it. Well, let's look at the alternate side of it. Now, what I'm actually going to do here is I'm going to create a separate class. We technically can do it. Let me do it this way first, and this is really something that is possible, but you would not very often see this done. Or you will very rarely need to do this. So I'm just going to put inside of my do something system.out.println. We'll do LOL. So all this guy does is print LOL to the screen. Okay. Is this a static method or a non-static method? Another way of asking is this a class method or an instance method? We know that this guy is not a class method because it does not have static in front. Not a static method, which then means it's not owned by the class. So when I say it's not a static method, it's also not a class method. It's like shorthand for saying not owned by the class. That means this guy must be owned. The alternative to that is it's owned by an instance of the class. Oh, and just so I don't forget here. There's the slides for class. Hopefully I'll remember to put it up in Blackboard later today too, but at the very least you have it in Slack. Okay, so this do something method, I was doing some stuff here. Instance methods. These methods are non-static methods. What has happened? Oh, it just crashed. Good. Oh, it's the Keynote update is available. That's the issue. So these guys are, oh, not now. Oh my gosh, are you serious? No, I can't use it without it. Just update that. Hopefully that's quick. Performance and stability improvements. I hope that's true, given the fact that it's unusable unless you update it. Okay. So it's just not an app anymore. All right. Oh, come on. That is so weird. Find the picture. There it is. So you like to say, Macs always work. 100% of the time, never have a problem. Just there. The real irony there is Keynote is actually an Apple product. So the Apple operating system did not successfully index an application that Apple writes after updating it. It's like the thing is incredibly stable now. You know, you're not going to be able to find it. It is stable.
So stable. By allowing the user to use it, it becomes less stable.
It will never crash because you can never open it. All right, instance methods are non-static methods, which means they do not have the static keyword in front of them. They are owned by an instance of the class in which the method was defined. And we're going to say an instance is a variable. Well, an instance is a value often stored in a variable where the following statement is true. Variable v is a whatever the class name is. There's that is a relationship. As an example, if I say string s is equal to hello, it is true to say that s is a string. S is a variable. It contains a value. The value contained in s is the string hello. It is true to say that that string hello is a string. Make sense? Therefore, that is an instance of the string class. Now, the reality is we're diving pretty deep into that definition. Most programmers would just say s is a string. Even though we're really trying, so I'm kind of driving home this idea that s is actually a variable that holds a value. The value it happens to hold is hello, which happens to be a string. Make sense? But once you become kind of annoyed with that deep dive breakdown, S is a string, okay? Because we're going to resolve it. It never stays in its variable form. All right, so instance methods are the antithesis of static methods. So these guys are methods that we need to exist once for every copy of an object, because the logic of the method might change depending on the current value of an object. Okay, so for example, let's go back out here. We'll just start looking at strings a little bit. I'm going to go ahead and dump all this stuff. If I create a string S, and that's hello, and I create a string S2, and this guy is elephant, and I say system.out.println s.length, system.out.println s2.length. We would expect to get two different numbers here, right? I am calling the same method. There is a method that exists in the string class called length, but I'm telling you it belongs to instances of the string class, not to the class itself. So if I go and I look up the length method in the documentation for the string class, will I find a static in front of it, or will I not find a static in front of it? It exists multiple times, once for every copy of the string. Therefore, it's an instance method. Therefore, it will not have static in front of it. Instance methods do not have static. Let me show that to you real quick. We go to the string class. Here's string. We'll go down to the length method. Here's length, no static out front. The length method returns the length of the string that called this method. Make sense? So the length of hello, the string that's calling this version of length, is the string that's contained in S. In this case, the string hello. The string that's calling this version of length is the string that's contained in S2, which in this case is elephant. So it should give me a 5 followed by an 8. Here's my 5 and 8. So let me ask you this. Is this legal? Did I do that? Well, once again, the omission of the red squigglies tells us maybe, since this thing's been acting kind of funny. Am I doing something any different here than I was doing right here? Am I showing you an alternative syntax? Or are those two lines actually identical? Well, almost identical that the value, because the values are different. What do you think? Are they identical? Cat, dog, or yes? Now this was an ABC, unfortunately. Got to understand the question, the problem before you, okay. So these are identical because what's going to happen to S2 at runtime? It's going to resolve to its value. So before this line actually executes, that guy's going to become elephant. So why did we put a variable there? Why did we say S2 instead of just hard code elephant in there? What's the value of variables? Use them again and we can change them. Their values can vary. Does the value of this ever change? That's a string literal. Once I just say elephant there, it's going to be elephant every single time I run this program. If I say S2 here, potentially the value stored in this variable could change. And what I'm printing out here is whatever the current length of S2 is, depending on what string currently lives in S2. So generally speaking, we would never actually do something like this. Because if I really wanted to do that, what would be the better way of writing it? If I was really interested in the length of Bob, what would be the better way of writing this? What's the simplest way of writing it? Such an interactive group. It's very exciting. Well, I can wait it out too. Just gonna think about lunch. Oh, this is already awkward. It's not a hard question, so I'm not going to let you off the hook. What I have highlighted there, what's the easier way of writing that? Well, I specifically in this case, what am I asking here? I want to know the length of Bob. So you're saying maybe I can throw it in a variable, then ask the question? That's actually taking an extra step, isn't it? So now I'm in a variable, I need to resolve that variable and ask the length of that variable. So we're going to say that that's less simple, but the only reason I would do something like that is if I needed to reuse it or I needed to potentially change it. In this case, I actually want to know the length of Bob. What's the easiest way to write the length of Bob? This is a good example of overthinking it. What is the length of Bob? All right, we got that one right. So no matter how many times I call that line right there that I have highlighted, what will the answer always, 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 always be? 3. Can I just write 3? Bob.length will always, always, always be 3. So if that's something that for some crazy reason I wanted to get, I needed to print out the length of the word Bob, I might as well just write a 3 there. Save myself some effort. Because it's going to take some time for the length method to go search through Bob and say, okay, well, here's the bucket 0, here's bucket 1, there's bucket 2. 3. I found 3 things there. I could just hard code the 3. Not something we would ever do, but this is that exercise of resolving code. Looking at code and realizing what it actually does as opposed to glancing at it and guessing what it might do. So that's something that beginning programmers often do. They look at code and it looks like it might do a certain thing, so they automatically assume that that's the thing that it does, rather than really going through it and seeing how it boils down. All right, so this is the same length method. That method was written one time. And that length method then gets, so this version of the length method knows about the string that lives inside of this variable. That is the string that's calling it. So we would call, in this case, hello, because S will resolve to hello. We would call this string right here the calling string. That is the string that called the length method. The string that owns this length method. This is an instance of the string class. Isn't it true what I have highlighted there for me to say that that guy is a string? Therefore, that guy is an instance of the string class. Therefore, that guy has access to all the instance methods of the string class. Therefore, I can call length because it's a non-static method or an instance method. Okay? And this guy will know that the length of hello is 5. This guy will know that the length of the string that lives inside of S2, which in this case happens to be elephant, is 8. Make sense? Now we're going to write an important slide here. Calling methods. The next two slides are slides that you will want to commit to memory. They will find their way onto quizzes. They will find their way onto exams. I'm going to have you repeat them over and over and over again in class to the point where people are thinking we're practicing a new religion. They're going to be a chant. All right? How do we call methods? So let's say static versus non-static. Static methods we call using an instant, we call using the name, put in caps, of the class in which the method was defined. So if we're looking at a static method, we call it using the name of the class in which the method was defined. Non-static methods, we call using an instance of the class in which the method was defined. That's how we call different types of methods. So if I happen to have a static method inside of the string class, I would call that method by saying string dot, the name of the method. Because that method is a class method. It is owned by the class, not an instance of the class. Therefore, I access it by using the class name itself. So a static method that happens to live inside the string class would be string dot. An instance method that lives inside the string class would be s dot, s2 dot, hello dot, some instance of the string class followed by the instance method. So this is calling methods. All right. Let's call this defining. Defining methods. Class methods. Defined using the static keyword at the beginning of the method definition. Instance methods. Defined without using the static keyword at the beginning of the method definition. So when we go to write a method, if we want it to be a class method, we put static in the front. If we go to write a method and we want it to be an instance method, we do not put static in the front. That's when we write the method. When we call, whether it's methods we wrote or whether it's methods that came with the Java language, we call static methods using the name of the class in which the method was defined. We call non-static methods or instance methods using an instance of the class in which the method was defined. That make sense? And then this kind of is a reiteration of one of these slides, but it's important for us to be for reading documentation. Identifying methods. Class methods have the static keyword. Instance methods do not have the static keyword. That make sense? So an exercise we might go through sometimes is I might say we're looking at the string class here. We're going to, let's introduce a couple of other methods for strings. So we're going to look at the char_at method. Here's the char_at method. Is this a class method or an instance method? Instance method. How do you know? No static. That's an instance method. How do we call instance methods? This is the chanting stuff. How do we call instance methods? Yeah, we call instance methods using an instance of the class in which the method was defined. Okay? What class was this method defined in? Class called string. So I'm going to need an instance of the string class in order to call the char_at method. So if I say s dot char_at 2, this is going to give me whatever char is at bucket 2 in S. This guy's going to return a char type. How do we know? Here's char_at. Its return value is char, the char primitive type. So I give it the index in the string. So whatever string calls the char_at method, in this case I'm calling it with my string s, which is hello. If I say 2, this is bucket 0, this is bucket 1, this is bucket 2. So it'll be this will boil down to that first L. That guy. If I said bucket 0, this will boil down to that H. If I say bucket 15, what will happen? It'll scream at me, right? So this guy will scream at me if I say bucket 15, because I don't have 15. I got 5 characters, legal position 0 through 4. Okay? Now, let's say that I wanted to print out every character that was in a string. I want to walk through the string, accessing individual buckets of the string. So we're learning the Java equivalent of this. So I already have my string S. Now, how many times am I going to have to loop in order to visit every character in S? Length of S times. But yeah, like 0 to length of S minus 1 is the legal buckets. But it's length of S times is the number of times I'm going to have to go through. Okay. In this case, S is hello, so I'm going to have to do something 5 times. But the correct answer, as you pointed out, was whatever the length of that variable is. Okay? That's how many times I'll have to spin through to do something with it. Now, I want to print out every char that's in that string 1 line at a time. So now I'm going to need a tool for extracting a single character from a string. Do I have that tool? Did we just learn that tool? What's that guy called? Char_at. So I have a char_at tool sitting here, so I'm going to take it out of the workbench. I got my char_at tool here. So this guy requires me to hand him a number, and I call this guy with a string, and he will give me the character in that string that lives at the position, the number I gave him. And strings are indexed from bucket 0 to bucket length minus 1. So hello has the H at 0, the E at 1, the L at 2, the other L at 3, the O at 4. Length is 5. 0 to length minus 1. Okay? So what kind of loop lends itself to this type of problem? How many times do I have to loop through again? Length number of times. or by this example, five times. So which loop lends itself to this kind of problem? For loop. For loops lend themselves to problems where you know exactly how many times we need to repeat something, right? All right, so we're going to write our stock for loop. What's the position of the very first character I want to visit in my string? 0. So I'll start I off at 0. I want to keep going. So I need my Boolean expression. I want to keep going as long as I have not walked off the end of the string. So I want to keep going as long as I is what? Is less than s dot length. Or if you prefer, you could say less than or equal to s dot length minus 1. So in our example here, I will start off at 0. It'll go up to and including bucket 4. What am I going to do with I each time? Add 1 to it. So
Is the length of S ever going to change?
in this example, it wouldn't. But if I change this to elephant right now, I don't have to modify this code.
Right.
In my example here, S would not change.
Right.
But it would be a pretty rare occurrence in programming for you to hard code a number in here, unless you said, I want to do something 100 times.
But like we don't have to get the length of S each time. We could store the length of S and then check.
Oh, I see what you're saying. You want to do this. You want to store length in s dot length. And then he wants to use length here instead of s dot length. What's the advantage of that? The reality is this would probably be a pretty rare occurrence. Most programmers wouldn't write it this way. This is legal, and actually this is faster. Why is this faster? That still has to look it up. This guy's still a variable, right? So it still has to go and look up that variable, the value stored in length. What's this guy? What kind of animal is that? Cat, dog, variable, or method? It's a method. Which do you think takes more time, looking up the value of a variable or running a method? Realistically speaking. A method's going to take more time. Which takes more time, driving to the grocery store or checking your car to see if you left something in there? It depends how far away the car is, I suppose, and how fast you drive, maybe. But generally speaking, we would say that methods are more time-consuming to call than the value of a variable. And what he pointed out here is, well, you know, every time I call this code, while I'm in this code, the length of s is not going to change. In this example, I mean, we could modify s inside the loop if we wanted to, but in this example, he's right. So really, we can store the numeric length of s once and then refer to it over and over again. And that would be accurate. Although you would very rarely see it written that way. Most of the time, you would see it written like this. And the advantage of this is we would ask the question, is this code that's going to have a performance impact? Is this something that we're really afraid might run too slowly? Probably not. This is going to be fast code. From a human perception perspective, the other version that I told you is technically faster isn't going to feel any faster. And this version probably reads a little cleaner. So we want to keep our code as easy to read as possible. You're better off erring on the side of my code is too easy to read than my code is too efficient. Okay? So we'll go through. We're going to say system.out.println s.charat. We're going to use our extraction tool, and I want to get the character at bucket I. So the first time through I will be 0, then it'll be 1, then it'll be 2, then it'll be 3, then it'll be 4 in this case. Then 4 becomes 5. Is 5 less than 5? It's not. We fall out of the loop and we're done. So this will print out HELLO, 1 character per line. If I change this to be elephant and run it again, I didn't have to modify my for loop at all. So one thing I could do is I could put this inside of a function. I'll make this a static function because it's going to be owned by this class. I'm just going to have to call it once. It'll be void. Call this guy print chars. Take a string s as a parameter. I'll steal that logic. Is this a class method or an instance method? Class method, how do you know? Static. How do we call class methods? Using the name of the class in which the method was defined. What's the name of this class? Driver. So we're going to say driver dot print chars, and I'll pass it my string. And there's my element. Make sense? For your homework, we're going to write 2 methods. One method called remove vals. So this guy should display each character in a string actually, let's do this. Let's call this display vals. Then we're going to have another one called remove vals, which returns a string with all vals removed. And then we're going to have reverse, which returns a string that is the reverse of the original string. So 3 functions. I would recommend you do reverse first as a warm-up. Reverse is going to be pretty similar to what we did here, which is a little modification, except the difference is that my version of reverse, I'm asking you to return a new string, not just print the string backwards. Yeah.
String is a valid return type in Java.
Absolutely. So for reverse, you're going to want to have that guy.
Okay.
Make sense? Questions, comments, concerns, bribes? All right, I'll see everybody on Tuesday, and I'll go ahead and post this code up on Slack.